Good morning, good morning, good morning. It's now Sunday morning, and no, it's not Sunday. It's a Monday morning. See, they have so many holidays in this country that I can't keep them straight. Yeah, yesterday I thought it was my birthday. I think that tomorrow's Thanksgiving. I know what you get. I know what you're thinking, and it's true. I'm getting old. So what happens when when you're young? You think about tomorrow. Don't stop thinking about tomorrow. Well, there comes a point when you're thinking about tomorrow, what you're really thinking about is passing over, if you know what I mean. I don't want to use the D word because it upsets my dog. It's the only D word he likes. And he keeps reminding me that dog is God spelled backwards, and I'm saying, well, are you saying that God is backwards or that you're backwards? And then he gets all mad and runs off and won't talk to me for 5 or 6 minutes. The only way I get any peace and quiet in this house. So, what happens when you're getting older? The older you get, the less future there is. So you do stop talking about tomorrow, because if you're going to be talking about tomorrow, you're talking about, you know what I mean? So, that causes those of us who are of a philosophical bent to think about, what's this life all about? What's this world all about? What is the meaning of anything? And so, of course, that takes me right back to where I first began my sort of serious studies. It brings me back to nuclear physics, quantum mechanics, the theory of relativity, atomic power. That's where I started my journey. When I was in high school, I read a book about Oppenheimer, about the Oppenheimer project, and about how the nuclear fission works, how nuclear fusion works, how the bombs are built. And so when I went to college, I wrote a paper on that in high school. And when I went to college, I wanted to go into the engineering physics department. So I enrolled in the University of Michigan engineering department. I was there for 2 years. After my first year, I declared that my particular interest in engineering was in physics, not structural engineering or civil engineering or any other engineering, so electrical engineering, but engineering physics. So what engineering physics is really about is about taking the principles of nuclear energy and applying them. So nuclear power plants would be an example of engineering physics. And I realized about halfway through in my sophomore year that really wasn't my interest in physics. My interest in physics had to do with curiosity. I wanted to know how things worked and why they worked. So I foolishly switched into the liberal arts department, and I majored in physics. I minored in calculus. And at the end of my 4-year stint at Michigan, where I got my degrees, I realized that not only did I not know anything, but I was more confused than ever. So instead of working on a PhD, and I had already started on a project that I had my faculty advisor. I was working on this project. We were trying to develop a radial distribution formula for a mu meson shower coming down from the lower stratosphere, which resulted from a proton-proton collision or interaction in that part of the atmosphere. Actually, beyond the atmosphere was the stratosphere. And the fallout from that collision was collected in a cloud chamber, which I'm not going to describe right now. It was located in the Andes in Peru. So I worked on that for a year, and we went a long way toward actually developing a meaningful formula. Then I said, you know what? This is not answering my questions. I want to know what life's all about. So I did the only thing that anybody does when they're really interested in knowing what life's all about. I went to law school. Yeah, I know. deviated as far away from physics as I could get. Well, it wasn't really true because I ended up with a pretty good career as a patent lawyer and a litigator in patent and antitrust cases. So it wasn't a complete waste, but it didn't bring me any closer to my answers. So now I'm old and falling apart, according to my dog, who's a spring chicken himself. And so I'm thinking about all this. And I'm not going to get into details right now. Right now I'm reading two books. One is on quantum mechanics, and the other one is on the general theory of relativity. But it's obviously the special theory of relativity is E equals mc squared, and that's the one that really matters for purposes of my discussion. And we'll have some time to go into some detail later. You're probably not going to follow, but here's a promise I do make to you. I'm not going to use any formulas except E equals mc squared and maybe the Laplace transforms and some reference to the Heisenberg uncertainty principle and Schrödinger's equations. But I'm not going to go into detail. One of the things that's frustrated me is I've known these formulas and used these formulas and worked these formulas, but I never really understood how those formulas were derived. So I was hoping to find this out from these two books, and guess what? They don't do it either. They just tell you the formulas. So you have to have some pretty good understanding of calculus and advanced algebra, and I mean really advanced, not the kind they teach in high school, to even work with these formulas. But my next project, should I live so long, is to go through and, for example, figure out, I've already got a pretty good idea how Einstein derived his special theory of relativity, but there's a lot of quantum mechanic formulas that I have yet to develop. And the basis of modern quantum mechanics is statistics, which is why Einstein never liked it. Well, who does like statistics, right? Except for accountants, and they're not really human beings. No, I'm just kidding. Oh, I forgot my accountant watches this program. Damn it. No, just kidding. I was kidding. Accountants are not just human beings. They're superhuman beings. They're the most wonderful people that ever walked the face of the earth or played with a slide rule. Oh, they don't use slide rules anymore. Okay. Oh, see, I told you I was getting old. So anyway, I've digressed. Why do I do that? Why do I always digress? Why can't I stay on the subject? These are the questions for which I hope to find answers in my renewed study of quantum mechanics and the theory of relativity. So, I'm just going to tell you this much. And here's what struck me when I first read about the basis for nuclear fission, which is the basis for the atomic bomb. And incidentally, when I talked about engineering physics, I used power plants. But the most dramatic example of engineering physics was the Oppenheimer project. They developed, and I'm sure you've seen the movie by now. If you haven't, go see it. Where that huge team of people at Los Alamos got together, and they actually did so much work. They figured out how to actually take the theory of relativity and Bohr's structure of the atom and all of that, and combine the Fourier theorems and put all that together and figured out how to actually convert from the theory into the actual explosion itself. So that was why I was interested in engineering physics. It was later that I really discovered I was more interested in how they got there than what they did with it. So if anybody tells you, says, well, explain to me the difference between the study of physics and the study of engineering physics, there you have the example. Tell them to go watch the movie Oppenheimer, and you'll understand that is engineering physics. And when they talk about how they got there, you'll understand that that's pure physics. So, I should quit on that. Look what I've taught you, something none of you ever even thought you would ever want to know, and now you all know it, and you still don't want to know it. This is why this is so frustrating. I've got to get a new job. This one pays terribly, incidentally. So, I got to get a job like Donald Trump. Yeah, so I can raise money to pay my... Oh, no, that's not me. Anyway, so once again, digressing. What an idiot. You're sick of my digression. Sick of them, I tell you. Shut up, Francois. So, here we are. There's the difference between the two. So, I'm just going to put one little bitty piece, which really got my attention when I was 16 at the time. And I won't say I was gifted, because I hardly ever got any gifts that I wanted. And you know what? That's still true. I'm not gifted yet. And I send my gift list to everybody I can think of. Total strangers get my gift list, and total strangers ignore it. And I gave up on Santa Claus years ago. I stopped writing to Santa Claus when I was 20. It just shows you what a cynic I was. Yeah, 20 years old, and I stopped believing in Santa Claus. Sometimes I still believe in him, but theoretically, as a figurehead, not as a real person. And nobody that fat can move around the world that fast. And what kind of an example is that? It's no wonder everybody has diabetes. It's just awful. It's Santa Claus. What a disappointment that man was to me. Is to me. He remains a disappointment to me, even now, even when I profess not to believe in him. I do believe in him. I just don't know why I don't get what I want. I still don't get what I want. I know the song, you don't always get what you want. I don't care about always getting what I want. They should write a new song for me called You Never Get What You Want. So stop asking. Who could I get to do that? The Doors? Are they still around? I don't think so. I think they closed the Doors. Oh, yeah, I know. Close the Doors, get it? And you'd like that one. Craig, the rest of you didn't get it. Okay, so here's the caught my attention. Finally, he's getting to the point. Well, E equals MC squared says matter and energy are interchangeable, and they're united by a formula. So you can calculate how much energy you're going to get from a nuclear explosion by how much mass you're converting to energy. So energy and mass are two sides of the same coin. I'm not doing this to illustrate a point. I'm doing this because I've got this muscle spasm. Two sides of the same coin. Side A, energy. Side B, matter. If you can convert matter into energy, you can also convert energy into matter. Hence the hydrogen bomb. So the Oppenheimer project, Niels Bohr, Albert Einstein, all of those people coming together, Fourier, all those people coming together, gave us actual proof in the real world that you can take matter and convert it into energy, which is completely unlike any other explosion that we've ever had before with conventional bombs, which is just like a rapid expansion of heat. So, you put the energy in, the energy comes out. You're not creating energy. With the atom bomb, you're actually taking a tiny, less than infinitesimal piece of matter, and you're converting that into a massive amount of energy, which is why there was so much excitement about nuclear energy in the first place, till people realized it's kind of dangerous. But from an environmental perspective, putting aside the danger and radiation poisoning and all that sort of thing, in terms of the atmospheric pollution, it's much better. It's much cleaner than oil burning power plants. So, but just think about that. You can actually take a piece of matter, this is matter, my phone, and I can, almost by magic, cause it to convert and change itself from matter into energy. So, what do you do with energy? You pick it up, put it in your pocket? Can you tie a ribbon around it? Can you send it to me as a Christmas gift? If you could, I'm sure you would. No, you can't. You can't hold up energy in your hand. So, what that tells me then is that what really matter is nothing more than an ordered state of energy. It's held into a position in an ordered state. When we destroy that order, the matter disappears. And all that's left is energy. It disappears. Now, what does it have to do with quantum mechanics? Okay, I'm just going to be brief. I'm going to do maybe a series on this, so you don't have to retain everything at once. And you don't need to understand math to understand these concepts. But the concepts, to me, have profound theoretical and philosophical implications as it relates to the questions I'm asking. Once again, I asked them when I was young, and now I'm asking when I'm old. I still don't know the answers, but the implications are there. And the implication is that really everything we think of as the real world, which means mass, which means, me and my dog and you and the computer and the lights and everything else, isn't really a solid at all. And it isn't even real. It's a mirage. And by that, what I mean is that the deeper and closer you get into the atom, the less and less material it becomes until you finally get out. Now you get to quantum mechanics, where quantum mechanics is shorthand for the discrete quantum of energy that is obtained by electrons as they move around the atom in discrete shells. But you can't see them there, because all you can do is calculate to a probability where they would be. And now you're talking about electrons, so you're talking about light waves, which means you're talking about are they particles or are they waves? And the reality is they have combinations of both. And then that gets you now into the wave mechanics and into the theory which has a solid mathematical basis, that what we really think of as matter is really nothing more than waves. So we will go into that later in some detail, but the point of this is the deeper and deeper you get into the subatomic particles, the less and less they appear to be actual particles, which had a lot to do with my original research project when I was at the University of Michigan. So, keeping that in mind, when we look at things, when we see stars, we see my dog, we see all these things, we're really looking at just ordered states of energy, which the deeper and deeper and deeper we get, they're like a mirage. They disappear. So, next time you look at yourself in the mirror, and you either like or don't like what you see, keep in mind you may not be seeing anything at all. You're just perceiving something. Keep that in mind, and we'll talk about this later. Maybe we'll figure out before we die where we go when we die, but somehow I don't think that's the plan. All right, kids. Talk to you later.